All right. So you got most of us here. I have got the grades just got finished. It's all right, Elijah. Actually, I was late myself. So I have the grades from the assessment we did on Tuesday, and actually, I think we did that on Thursday of last week. Whenever we did it, I got those grades put into Home Access Center and also into the Google Classroom. There are still a few of you who did not get the work done. So please get those to me as soon as possible. All right. So I put a list of items, 5 different items, into the Google Classroom to see if you could possibly get from around your house. Really didn't want anybody to go out and buy them because if this is not something you have at your house, I don't want you just to be spending money and have it thrown away. Well, nothing is really too expensive. I'm sure your parents don't want to just spend money for the heck of it. So, first off, what I want to do, I'm going to share my screen with you, is I want to talk to you about the last question in the assessment real quick. If you look in today's Google Classroom assignment labeled How Do We Smell, there is one document in there that says Lesson 12 handout comparing molecular ratios. So when we look at the two different models that are presented, I know it's slowly loading up on mine. It shows us the citric acid, baking soda, and water molecular reaction. So let's say in model A, we have 3 citric acid molecules, we have 3 baking soda molecules, and we have 3 water molecules. These are known as reactants. These are on the left side of the reaction. So you have your reactants on the left-hand side. A yield, this means to make or to produce or to create. We have 1 sodium citric molecule, 3 carbon dioxides, and 6 water molecules. Now, model B, everything on the product side, and that's what we call the right-hand side of this. Sorry for not filling that out. The product is the same as in model A. So model A and model B, their products are identical. However, here on the left-hand side, the reactant side, I only have 1 molecule of citric acid, 3 molecules of baking soda, and 3 molecules of water. What I would like you to do is in the chat, I'd like you to tell me by looking at them which model looks more likely to be the actual representation of the chemical reaction of citric acid, baking soda, and water to produce the carbon dioxide we've been looking for. So take a look at those 2 models really quick and tell me which one, in your opinion, looks the most correct. Okay, if you go into the Google Classroom, into the classwork section, week 19, it's under the week 19 Thursday, How Do We Smell? It's the lesson 12 handout. All the rest are, say, either lesson 13 or there's a video, and I meant to delete that video because I'm going to put the new video up there. But it's the lesson 12 one. Do you see it? Not a problem. So, and as soon as you have your opinion, like I said, please go ahead and put it in the Google chat for me. Praneeth, it's perfectly all right. I was late myself. You are here now and here before we really got into the nitty gritty. So we got two A's, we got a B. Only 3 people have committed so far. A, B, 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 B. Ba 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 boom. Oh, sorry. You don't need me to terrorize you with my melodious singing. Ba boom, ba 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 boom, ba 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 boom. All right, so it looks as of right now, B has just a few more than A. So, first off, I want to go ahead and ask Daniel, how are you doing, sir? I'm doing pretty good. What compelled you to pick A? What is your reasoning behind saying A? Okay, no, it only had one sodium citrate, but it had more citric acid. There were 3 citric acids versus the one over here. Okay. Jacob, how you doing, sir? Yeah, yeah, yeah. Excuses, excuses. No, I'm just joking. Um, so why do you, sir, say B? Okay, not a problem. Sir Path, I'll come to you in just a minute. And Shrieker. Yeah, that's been about 4 seconds now. You keep saying 1 second, but you know. Okay. Well, I mean, do you know why you picked it? Okay. So you're just because it has all 3 of them? All right. I'm gonna see what Surpath has to say here. Surpath, you have a comment? You want to say something? On which one? And that is it exactly. Shrieker, before I go on with this, was there something you wanted to say? Right, of B. So this comes back to the whole law of conservation of mass. If we look at model A and we're going to just look at the carbons alone, we have 1, 2, 3, 4, 5, 6. 6 times 3 is 18, 19, 20, 21. And over here we have 6, 7, 8, 9. So I have way more carbons on the reactant side than I do on the product. They have to equal each other. So if I come down here and look at B, I have 9 on this side and I have 9 over here. I have 3 sodiums, I have 3 sodiums, and so on. All my atoms are equally accounted for on either side of the yield sign. And according to the law of conservation of mass, that must always be. Whatever you have on the reactant side must be present on the product side. So, we basically broke these down, rearranged them, but they have to be the same. So, does that make sense to everybody? Okay. And again, that's not something we had really broken down and talked about before. We're actually going to talk a little bit more about that in the next unit as we come up. But that's just something that I wanted to see if anybody would lock in on that. One of the things, and I'm not saying anybody in here did this, I'm not accusing you of doing anything, but one thing I notice every once in a while is once somebody commits to something, you get other people will follow along with a person that says something. And that's why I usually will skip the first couple people and then, see. And again, I'm not saying that's what you said, but I've actually had a lot of people think it was A because there's just more stuff and they think it'll be more easy for them to make the carbon dioxides or something like that. But anyhow, all right. So I'm going to get off the present. No, I'm not going to get off the presenting yet. So we don't need the lesson 12 anymore. I'd like you to go ahead and open up the reading handout on lesson 13. It is how do we detect odors? I'm going to give you about 5 minutes. I want you to read this handout on your own. Just read it real quick and then hold on a second and I'll be right back with you. So hopefully you're all able to open that up without any problems. Yeah, I get it, Jacob. It was a little confusing. That is true. The reaction does yield a lot of water. All right. So hopefully you are wrapping up the reading right now. Let's see here. Jagadish, how you doing, sir? Jagadish, you there? Okay. So, sir, what describe in a very, very simple way, how is it that we smell? Okay. Okay. Um, Ramchan, right. How do we detect the odors? How do we smell something? Okay. So, what the article is telling us is that the the items that give off odors, the particles will drift off into the air. And as they do this, they come into our nose and we have a mucus lining our nose. It's not something really nice to think about, but there's our noses need to be moist. They need to have this moisture in there. And when the particles land in this mucus, the mucus actually helps dissolve these odor molecules. And it sinks into the mucus into what is called olfactory receptacles. Now, it usually will take a couple different molecules to fire off a recognition signal in our olfactory receptacles. And when it does this, it categorizes that smell by whatever we determine it to be. Um, so it tells you in there the smell of lavender. It takes 7 different molecules from the lavender scent to have our body register that smell of lavender. So once it's registered in there, next time I smell it, my body is going to know it's lavender. It's automatically going to start making associations with that smell. So if you come back and you look at the diagram that was in the drawing, and let's see, let me go ahead and blow this drawing up just a little bit. Oh, come on. There we go. So you have this big old nasal cavity right here, which is all inside of our head. And actually, my brother had the cartilage of his nose broke, and they actually put 33 feet of gauze in this little cavity right there. It's a pretty good size cavity. Well, you see, there's these little hairs up here, um, and the mucus is covering all inside here. And these little hairs, these little receptacles, as you will call it, this is what will take that smell and then transfer it into our brain. Kind of a pretty interesting machine, if you were to call it as such. Okay, so what we have now is we have a document. It says handout odor lab. If I go ahead and I open up the odor lab document, there are 3 columns. Substance is the first column. What you notice when you waft, and that's the method of bringing a smell to your nose, not your nose to a smell. What does it smell like, and what does it remind you of? So, like, one of the first things we're going to do, the first one we're going to try is actually lemon juice. Now, I don't want you to say lemon juice smells like lemons. No kidding. I would hope lemon juice smells like lemons because that's where it comes from. I want you to try to think, those of you that have the products, I want you to kind of think about what else it smells like to you besides that smell. Maybe, is it bitter? Is it sweet smelling? Something like that. And then whether you have the products or not, if it reminds you of something from the past when you smell these smells, write down what it is that it reminds you of. And we'll come back after we smell all 5 of these and talk about them and do this last column. Now there are only 4 rows here, so you need to make another row. Actually, do you have 5 rows on yours? I think I made the extra row for everybody. Well, Leighton, then if you don't have any of them, you're writing down what we talk about in class. Okay. So starting off with lemon juice. Those of you that have lemon juice, get it out and you can add to the conversation as we're going along. So I shake mine up just a little bit to get the smell kind of moving around. To me, it smells sweet, kind of not very strong smelling. Um, it reminds me of cleaner. When I was in the military, we used a citrus-based cleaner to disinfect everything. And that's the thought that comes to my head when I smell lemons is I automatically think of this Echo Lab cleaning product I used when I was in the military. I'm not a big lemon juice or lemonade drinker, so it doesn't really remind me of lemonade. How about somebody else? Does anybody else have anything they want to say about it? What it smells like to them when they smell it, or something it makes them think of? You don't have to raise your hand. Just go ahead and say it if you have something you want to put in there. Okay. Super fresh oranges squirted in your face. Anybody have anything else? Shrieker, were you the one that said that? Okay. I thought so. I just wanted to make sure. Elijah? Right. Okay. A lot of cleaners have lemon in them to give you that smell. Anya says it smells like summer. And I'd kind of see that, especially if you ever drink lemonade. Lemonade's a big summertime drink. Um, very good. Okay, so the next one I have, mine happens to be lavender bubble bath. Some of you may have some other, I've had people have lavender hand lotions, lavender shampoos. Some people have had essential oils. But when I smell lavender, to me, it smells like perfume. Um, my wife and daughter both use it's called a body splash. It smells very flowery to me. Um, feels Smells very sweet, very fragrant. Makes me think of maybe being in a meadow somewhere. Um, yeah, I mean, it's a very pleasant smell. Lavender is used quite a bit to help people relax as an essential oil. That's one of the things it does. It relaxes you, supposedly, if you are into essential oils. Um, had somebody tell me last class that they have a diffuser that they put lavender in right before they go to sleep because it helps them sleep better. How about you guys? Go ahead and share some things that you might have about lavender. Okay. Calming. Carson, how about you? Oh, I mean, that'd be a good smell. And I wonder if it actually would calm him down as well, if he's a little on the hyper side. Okay. Hey, Chopper, it's fine if you don't have any. Like I said, you're just writing these down then as we talk about them. Daniel, it smells like a fresh blanket coming out of the dryer. Very possible. I mean, depending on what kind of dryer sheets you use or what kind of laundry soap you use. Ramchan, open field of grass. Yeah, a lot of flowers in there. And Holden says, it smells flowery and garden-like. Like I said, I mean, it's a very fragrant smell. It's uh, it's pretty cool. I mean, I like it. I personally don't wear anything that has lavender because it's a little more on the girly side than I want to wear. Not that I'm afraid. What soap was this? It's not really a soap. It's a scent, but what I have is a lavender bubble bath that I bought at Walmart for this. Smells like wet wipes. It very possibly could be a spa. A spa would definitely have it because it helps you relax. No, Ramchan, we're going to come back and talk about the molecules after we go through all five of these because that's something I'm going to turn you loose on to do by yourself. Um, Akriti, the lavender smell is light. What are you smelling? Okay. It's not like an overpowering scent. Okay. Okay, going on to the third one that I have. It is a brown liquid. It is called vanilla. I'm actually using imitation vanilla. There's imitation vanilla, real vanilla, vanilla extract. They all smell really kind of the same. Um, when I smell vanilla, I actually think of a chemical. Kind of smells kind of chemically to me, but at the same time, it has kind of a candy smell to it, which is kind of weird. Chemical and candy mixing together. But that's just the way my brain kind of relates it. Um, I when I smell vanilla, I think of either my family baking. My wife and my daughter love to bake cookies and cakes and stuff like that. But the biggest thing I think of is my coffee. I drink coffee with a lot of caramel vanilla creamer in it. So Jagadish thinks of ice cream. Vanilla ice cream is my favorite. Bakery, yeah. Holden says smells like something in the bakery or sweets. Um, Acredi also smells very creamy. Hershey's cookies and cream. Yep. Yeah, so I mean, vanilla is a very unique smell. Really gets you, I don't know, almost kind of hungry sometimes, especially if you haven't eaten. Carson, I see your hand is up. Was that from earlier, or did you have something you wanted to say here? All right, I just put it down. That's fine. Oh no, no, don't, no need to say sorry at all. Thick stuffed chocolates. See, now you guys are, you're making me want sweets. And actually, what sweets do I? I have some sweets around here somewhere. The only sweets I have are coffee candies from Colombia. My daughter and her husband went to Colombia for Christmas and New Year's. Bought me back some really good coffee candies. Okay, going on to our fourth liquid, clear liquid. Shake it up. Smells like, well, it is. It's vinegar. It's acidic acid. It's very pungent, very powerful smell. Kind of, smell it, and, to me, kind of takes a step back. It's very distracting after you smell something powerful. Okay, so those of you who are writing in there, what you might have to do is check the color of the font. For some reason, some of it is in white. It just needs to be changed to a black color on the font as far as writing the boxes. Um, when I smell vinegar, it reminds me of Easter eggs, which I don't know if everybody here has ever made Easter eggs, but you get a cup full of vinegar, put a little color tablet in it, and then set the egg inside of it, and it will dye your Easter egg shells. Let's see, you got a couple. Arsh, what do you think of, or what do you have to comment on that? Uh, oh, I'm sorry, vinegar, acidic acid, vinegar. Okay, something like ocean water, something you smell in the ocean. Yeah, so it can be, especially like window cleaning products. Vinegar is used quite a bit to clean windows. If your parents ever tell you to go clean some windows or something like that, and you don't have any Windex or something, you can get vinegar and water and put it on there. It'll clean your windows without any streaks on it. It's often found in a lot of Windexes. Anybody else? Anybody have anything else to add to it? Yeah. Okay. Elijah. Okay. It is a very good. Oh, go ahead. Right. Is it? It is an acid, so it is a very good disinfectant um, for sterilizing things. Something I don't know if you've ever seen or not, which is kind of interesting, is if you get a cup of vinegar and put an egg in it, let the egg sit for a couple days. It's actually called the invisible egg. It will dissolve the shell, but leave the membrane of the egg intact, and you can see the egg without a shell on it. It's kind of neat. It won't cook the egg. The egg will still be raw when you do that. Yep. Streaker, you have a question? Nothing. You can consume vinegar. Um, it. I mean, I don't know about large quantities of it because it is acidic. So it can actually cause you to have an upset stomach. But vinegar is what makes pickles. Vinegar and oil is a salad dressing. Vinegar is used in Chick-fil-A chicken. Have you ever eaten a Chick-fil-A? Um, yeah, I mean, it's consumable. It's definitely consumable, but it's an acquired taste. I'm not a I hate pickles. I think pickles are disgusting. Um, I don't like vinegar and oil salad dressings. Um, I love Chick-fil-A chicken, but yeah, I'm not a big fan of vinegar, but when it's used in the right amount with different things, it's good. Yeah, again, hold it. It's not that it, I mean, you can actually drink a cup of it, but it's going to upset your stomach. And if you drink too much of it, it would probably start to cause you ulcers, start to eat holes in your esophagi, your stomach, and your intestines. So, yeah, I mean, it's not something I'd want to do, not to mention the fact that, vinegar by itself just is not pleasant. It does not have a super pleasant taste. So, yeah, do it in moderation if you want to drink it. I don't recommend it, but okay. The last one is menthol. What I have is a gel. I got this out of the Equate version of Vicks Vapor Rub. Vicks Vapor Rub is something that is used a lot of times if you're sick, if you're really congested, you rub it on your upper chest. It'll help break up your congestion. You can rub it by your nose. It will help alleviate stopped up noses and stuff like that. You can find it in cough drops, but when you smell it, it's it smells minty almost, kind of like a mint. It is a Swedish sour smell. This is menthol. Um, it's very pungent. It's a very powerful smell. Um, Myself, it reminds me of like a doctor's office. I don't know why that smell kind of makes me think of a doctor's office or being sick. Um, I don't know if you guys have these humidifiers. They're probably like a foot and a half by a foot and a half plastic. They're about, so tall. You fill them up with water, put a little bit of salt in the water, and then put this device inside of it, and it evaporates the water that's in there, and it'll shoot out a stream of steam. Well, you take this Vicks Vapor Rub, and you get a dollop of the gel and put it right by where the steam comes out, and it puts that menthol into the air with the humidifier when you're sick. And so you breathe it in over the course of the night, and it actually helps you as far as your breathing goes. It makes you breathe better. Yeah, eucalyptus oil is another one. So, anybody else have anything to add or say about menthol? Or did that kind of cover it for everybody? Okay. So, you should have been writing these down, any kind of observations that I gave you, or if you had your own stuff that you had in the center column right here, under where it said, what you noticed when you waft, what does it smell like to you? And if you've ever smelled them before, tell me what it reminds you of. Because, like I said, smells trigger memories, kind of like music does. I don't know about for you, but I hear certain songs and it reminds me of different things. Your brain likes to attach memories to certain things. So it's just a way, it's part of our filing system in our brain. So now this last one, what did you notice about the related molecule? Oh, excuse me, pardon me. What did you notice about the related molecular model or models? Now, lesson 13 handout on molecular models of. So if we open that up, and my computer has just been running so slow today. I think it's just the internet is really bogging things down. It will show us when it finally opens up the model of each one of these. So, here's the model of what vinegar looks like, acetic acid, gives you the chemical formula. The chemical formula of limonene, which is where the lemon odor comes from. Vanillin, which is where the vanilla odor comes from. Come down a little bit more, the menthol. The menthol itself is an odor just by itself. Doesn't have its own separate odor molecule. And lavender is actually two different molecules help make up the 7 molecules needed to register that scent. One is, and I'm probably going to say these different, but I call this one lanolol. And the other one is lanolol acetate. So what you're going to do is I'm going to go ahead and I'm going to explain with lemon because that was the first one I did. So limonene, when I look at the molecular model, the very first thing I notice about limonene, especially compared to everything else, it has no oxygen molecules with it. It's the only one of the 5 or 6 molecules that does not have any oxygen. So I'd write down, does not have an oxygen molecule. It's based, it's center based on carbon. It's a large molecule. I mean, it has 26 atoms altogether to make up the smell of lemon. And that's all I'm going to do. I'm going to go and do that for each one of the substances. Vinegar, I'm going to write down what I notice about vinegar's molecule. I'm going to write down what I notice about the vanilla molecule, and so on and so forth. So does that make sense what I want you to do in that last column? You're just basically going to describe what you noticed about those molecules. Yay. Go ahead. Right. Well, then go ahead and write down some of the things that we talked about. I'd be really surprised, though, if you have not actually smelled all those smells. Menthol would probably be the least likely one you smelled. But if you go anywhere into like Walmart or something like that, if you've ever walked in the bath and the bath area where all the medicine stuff, you've probably smelled lavender. But if you didn't know it was lavender, you might not put a scent to it. Just put down what you can, but if anything, just go back into the video and write down some of the things we talked about. Really, Chopper, it's hard for you to remember smells. What's your favorite food, sir? So when you walk into a house, can you tell if there's been a grilled cheese sandwich cooked or not? So it's not that hard for you to remember smells. You just don't want to remember some of them. Leighton, that is in Google Classroom under this with this assignment. It's called Lesson 13, molecular models. Okay, I see what you're saying. So tell me if you think it's go back to the things that I said. Is it pungent? Is it strong? Is it fragrant? Tell me that based on what we talked about in class. And then once you're done with the writing out the descriptions of the models, then you can go ahead and submit it.